Welcome to Wired In, the show that connects you to the latest advancements in electronics and high-tech innovation. I'm your host, Steven Humphrey. From product lifecycle management to supply chain strategies to emerging AI use cases, each episode delivers practical insights and in-depth discussions with leaders shaping technology. If staying ahead in the high-tech sector matters to you, you're in the right place. Today, I'm joined by Alex Daly, PTC's industry advisor for the federal aerospace and defense industry. He has deep expertise in digital engineering and defense systems and has spent his career helping defense organizations modernize their product data and engineering strategies. He's the ideal candidate for today's topic. How is artificial intelligence transforming the aerospace and defense sector? From factory floor AI to its use on attritable and exquisite platforms alike, we'll unpack trends and innovations adopted from high-tech industries. Let's dive in. Alex Daly,
Steven Humphrey.
Great to see you again. Thank you so much for joining us today.
Thank you.
Oh man, I'm excited to have this conversation today. All right, let's dive right in. I want to talk a little bit about innovation. Now, historically, I don't think most people would say the government is known for extremely high levels of innovation. Conversely, on where I sit in the electronics and high-tech space, very high levels of innovation, very compressed product cycle times. Mm-hmm. But I think we're seeing a bit of a shift there, and we're going to talk about that today. So I'd love to hear more about what you think about how do you see this pace of innovation shifting? A lot of it because of AI and just how fast things are moving today. Mm-hmm. How is the U.S. government and some of these major defense primes that you work with, how are they finally getting in on the action today? Mm-hmm.
Yeah, I think so. It's two converging roads that we really haven't seen ever before between the very large-scale defense primes, of course, many of the smaller startup firms that are out there in the national security world, and the government, and they're all three making major moves on the AI front. For example, if you look at RTX, they're deploying AI capabilities in fourth-generation fighters on F-18s for radar systems. That's one. Number two might be Lockheed Martin, who's created a subsidiary company specifically focused around AI infrastructure and deploying that capability to customers either in government or elsewhere in industry or both. And Northrop Grumman is a third example where they're actually using an AI capability to do telemetry analysis for satellite health monitoring. I mean, That's just the tip of the iceberg of the type of use cases that we're seeing out there in industry. And of course, all three of those companies now have major strategic initiatives underway with NVIDIA. Again, talk about two converging roads. We weren't seeing that happen 2 years ago. You're seeing it happen now.
Wow.
NVIDIA, another good example, is also doing a lot of work directly with the US government. Take the Department of Energy. Mm-hmm. They're partnering with NVIDIA to deploy their capability to build out supercomputers on either the civilian side or the weapons side of the house within the DOE. And also, it was just announced very recently in the Pentagon is that NVIDIA is going to be deploying their capability in classified environments in the government. So again, just a major shift that's happening in a macro way, and it's happening at a very fast pace.
Yeah, no, I couldn't agree more, and thank you for that insight. I mean, it's, from where I sit on the, kind of the private sector side, electronics and high tech, and we think, hyperscalers and the Googles and Metas and NVIDIAs of the world.
Sure.
For me, it's all about like really short, life cycle and development times and really high levels of innovation. And I think traditionally, you wouldn't maybe think the government and aerospace and like these big legacy companies, if you would even call them that today, would start to, coming into that mold, if you will. But It sounds like they are. They're embracing it. They're partnering with some of these high-tech companies, right? So, I mean, it's really exciting to see and the kind of convergence of, the high-tech evolution and development and how it's being applied into these other sectors like aerospace and defense.
True. Well, it's not just about bringing on board new capability, but also scaling the production of existing capabilities.
Sure.
And again, you're seeing the importance and the urgency around new capability development, essentially in all industries right now. But I would say, particularly to aerospace and defense, it's to scale up the production of things like long-range precision fires, missiles. That's part of the urgency around the demand signal for all of this. For example, RTX and Lockheed Martin, the CEOs of both of those companies, have made commitments to the Pentagon that they're going to be either doubling or even quadrupling missile production.
Wow.
And again, that's something that you weren't seeing 18 months ago, you're seeing it now. And so that's one thing that we've been focusing on a lot in terms of our capability around integrating engineering functions to manufacturing functions, just to scale up what's already been designed.
Sure.
And again, that's where the urgency is coming from.
Yeah, and I want to dig into the digital engineering piece here and just to kind of highlight some of the differences between our industries, right? For an E&HT, often it's developing those new products, like getting your product development timelines compressed and getting new products to market as fast as you can to be competitive.
Sure.
Whereas in your space, it sounds like scaling up existing capabilities to really meet that demand and get things out the door as quickly as possible.
Another really good example is L3Harris. Their missile systems business just announced an investment from the U.S. government directly, the Pentagon, of $1 billion to scale up production in that business. Again, it's almost similar to what you saw in the United States in the automotive business around the time of the financial crisis in 2008. You're just seeing it through a sort of defense lens right now. And again, it's not just in the US, you're seeing it everywhere. You're seeing the urgency with companies like MBDA, missile manufacturer out of Europe. You're seeing it in Asia, you're seeing it in the Middle East. It's all just the same thing over and over again. The urgency is at a fever pitch.
Wow. It is an interesting time for sure. So let's talk a little bit about the digital engineering piece here, because in our respective industries, they're maybe a little different, but accomplishing similar things, right? So when we think about the intersection of digital engineering and AI, right? How does that help these companies make the most out of their data, especially as things like standard bodies, for example, I know the government's pushing big on the digital engineering piece for some of these companies.
Right.
For things like digital sharing and being more collaborative while also continuing to protect state secrets and things like that.
Sure. Well, I mean, a big part of the digital engineering conversation, of course, is data rights in the aerospace and defense business. And this is an issue that has been, it's been a challenge inside this business for quite some time. I mean, I'm going back decades now. And it gets back to this central concept of both sides have a sacred right in this grand negotiation. On the one hand, you have aerospace and defense firms who deserve to be adequately compensated for their intellectual property. That's a normal thing. Costs billions of dollars to capitalize your own research and development, to bring a new product to market, and then to scale that production. And then on the government side of the equation, increasingly the government is saying that they must utilize this data, not have ownership of, but at least access to, in order to scale up the needs that they have. And increasingly, we're seeing, again, the demand signal for the government in asserting its right to have at least some access to that data. There's two important laws in the U.S. that are under consideration right now. One's called the SPEED Act, the other called the Forged Act, to use contractor data from the defense primes for either maintenance functions or manufacturing functions. But my market thesis, and I think our market thesis at PTC, is how long before that contractor digital engineering data is used for what? Artificial intelligence model training.
Right.
We know it's coming. Again, another set of converging roads. So again, time will tell. We'll see how it shapes up.
Yeah, well, and I think this is consistent with what, talking about those innovation cycles again and the differences between our industries. Like today, a lot of our customers and a lot of companies I talk to, they're already using AI to train, physical AI training models for manufacturing, for simulating, digital twin environments for simulated manufacturing, and how is this piece of equipment or this thing going to operate in that environment. It totally follows that you would do the same thing with a boat or a plane, and the more money you can save on that physical AI kind of simulation environment is less money on prototypes and ramping up to build something that isn't quite perfected or ready for prime time yet.
Right. 100%. I mean, this gets back to our original conversation from a couple of months ago. This is really one thing that NVIDIA and Jensen Huang have been speaking about for quite some time, this idea of physical AI, physics, friction, and inertia, where you're trying to train a robot, for example, on how to actually interact in the real world. And again, our thinking on all of this, and I don't know exactly how it's going to shape up, but I know it's true, is that the outputs of digital engineering at the product data level are about to become the inputs that train AI models for physical AI.
Sure.
So how do you train that robot to understand, for example, the difference between a tennis ball and a baseball? And instead of throwing that product at a wall a million times, it's much quicker to just take a look at the data for those two respective products. Well, where does that come from? An engineered bill of materials,
Right.
A requirements document, a testing procedure, a CAD file. And that's why I think companies that are in the digital engineering space are going to be especially relevant in the physical AI era in which we're entering right now.
We are, and again, I think there's a lot of corollaries between our industries, but also some differences as far as end uses and applicability of what that model might output or what that training might look like.
Yep.
But I couldn't agree more. And I mean, from where I sit, a lot of the companies we're working with are at the tip of the spear. They're already doing this. They're working with us to develop, some new innovative ways to leverage that product data. And it's for a lot of it, it's just to better simulate inserting, a cable into a connector. Because if I can save 5 seconds on that on the assembly line, I can assemble 10,000 more products, a year, and that hits the bottom line. So different use cases, different outcomes, but the physical AI world is 100% coming, and I think how do we help our customers and the companies we work with be prepared for that?
And just think about the aerospace and defense iteration of all of that. If you're a military commander, let's just take a naval example for something like maritime domain awareness. Right now, the majority of those use cases for artificial intelligence are trained on operational data. What is the weather doing? That's the most important factor in the battle space. Where is the enemy? What are the electronic warfare constraints that we're working under? Where are the available ports? That kind of, all of that data from an operational context is critical.
Yeah.
But our thinking at PTC is that eventually those same models are going to be utilizing what? Digital engineering data. What is the operational readiness of that impeller on that carrier? Or that Mark 45 weapon system, or that electronic warfare system that's on that destroyer? I mean, it's all going to get into the realm of product data, and that's where PTC has been for the last 40 years.
Absolutely. And a lot of these companies are sitting on a gold mine of product data, but how do they really get the most out of it, right? And how can we help them? How can industry come together and start putting in place standards? I mean, for example, we talked about NVIDIA, and we see, like in my space, things are moving very fast, right? The government can't keep up to make enough rules and policies, in time. It seems like we hear announcements about AI companies doing all kinds of things.
Yep.
But in the next 5 years or so, I imagine we'll start to see some of this coalesce around real world use cases and a standardized approach to some of this stuff, right?
Well, that's the X factor I see in all of this. I don't know exactly how it's going to shape up. No one really does.
Sure.
But I mean, it's like the people who built the railroad tracks knowing that the locomotive was eventually going to come into existence. And so I think eventually many of these participants on the industry side of the equation are going to figure out how to monetize that basis on a per model and a model specific basis. And again, there's going to be some shaping up of the regulatory environment, the policy environment, and also the contracting environment to figure out how all of these demands meet their supplies. And again, time will tell.
And when I compare and contrast the differences between our industries, right? Like I consider EHT a lot of the times kind of the tip of the spear in high tech and like what's coming, what's the latest and greatest.
Right.
We look at the levels of innovation; they're very high. The product, cycle times are very low. Whereas contrasted with your industry, it's traditionally been a little flipped, right? Longer cycle times. These products are in the field for decades, right? I mean, I know that there's still some B-2 bombers still flying around, right?
Sure.
And lower levels of innovation. But it seems like there's a transition happening now in your space, and maybe some of that's powered by AI. So could you talk about that?
Yeah, well, I think it's partly this kind of schism between attritable systems and exquisite systems. And again, just a short definition of that. An attritable system might be, say, a fleet of drones where you can lose, say, 80% of that fleet, but still accomplish the mission. Thus, they are individually attritable, but collectively, they're highly effective. And then the inverse of that, of course, is an exquisite system, like bringing a new fighter jet online. The reality is that we need both.
Yeah.
And governments and militaries around the world need both. And AI is going to be infused across both of those types of platforms. And I will say that, this idea of electronics and high tech being the sort of substrate, if you will, from which all of the other industries are going to be springing up like, individual plants. And one of those is aerospace and defense. And I will tell you that there is a hunger inside governments and inside militaries right now to learn from other industries that perhaps hasn't, it's always been resident there, but it hasn't been as intense as it is right now. The Pentagon, for example, has created a new organization, the Business Operators for National Defense, the BOND.
Wow.
And the whole idea behind this organization is to learn from other industries and apply that quick turning radius, if you will, inside the U.S. government, but also inside the defense industrial base. And I think that we're seeing the same type of embrace in governments in Europe and governments in the Middle East and also in Asia.
Yeah, no, and I love the idea of the substrate, right? Because, of course, I'm a little biased, but I do like to think that, electronics and high tech does kind of touch almost every industry. Nowadays, everything has some type of device or chip or component in it,
Right.
and your industry is no different, right? So the opportunity for some of these, high tech innovators like an NVIDIA or a Google, or even some of the startups in your space that are
Right.
coming up, rapidly, to collaborate with the government and some of the traditional primes to bring in those new levels of innovation. AI is a great kind of opportunity to we still don't know exactly what AI is going to do to all these industries. It's easy for us to hop onto a chat bot and ask some questions, but to our conversation around physical AI, right? Like the operational envelope of a mission, right?
Yeah.
That's very different than what some of my customers are doing, which are trying to scale high volume manufacturing and shave off a few milliseconds in a particular process,
Yeah.
but using the same tools to do it. So it's a really cool, I think, opportunity to explore that overlap and the complementary capabilities between those businesses.
It's true. We're seeing an embrace and an adoption of artificial intelligence, not just from a compute standpoint or a data standpoint or algorithms, but just from an overall operational standpoint. And this gets to the idea we were talking about earlier, sovereign AI, where individual nations are in charge of their own AI future. I don't mean to oversimplify it, but that really is what's happening right now. And then if you get as a substrate of that, this idea of export financing for, say, one country trying to export its AI capability in the context of its own diplomatic endeavors.
Sure.
And deploying within its own military, for example, or getting down to the firm level where you're focusing on, the cultural realities of artificial intelligence and how do you train and embrace your workforce to get them ready for this massive shift. It's the most important technological shift of our lifetimes for sure.
Yeah, no, that's incredible.
And that's where we're going.
And that's a great point you bring up with sovereign AI, because we're kind of both on that side of the coin to some extent, right? Because I would love to get an official definition of what sovereign AI really means. But when we think, why is this critical for both tech companies and defense companies and defense agencies, right? So a company like NVIDIA or OpenAI, they're the ones helping develop the frontier models and the hardware.
Yeah.
But then from a sovereign AI perspective, how the government's going to use that and what their role is, right? That's very different than like a consumer chatbot.
Sure.
Right? So maybe you could elaborate a little bit on that.
Yeah, well, first of all, it's all new territory. And I think that we're sort of printing this on the snow on the top of the mountain that we've never been on before.
Sure.
So it's all new. It's new to the government, it's new to industry, and everyone's sort of feeling their way through the darkness and looking for the light switch. There's no easy answers to any of it. But again, I've seen a lot of thought leaders in the national security space where I live in Washington, and they're talking about things like export financing, or how is it that from a commerce perspective, we can embrace the right types of companies that are advancing and accelerating what, say, one country A might be trying to do from a diplomatic standpoint. The whole point is that there's a diplomatic undercurrent within artificial intelligence, and you're seeing it with the leaders of many of these AI-related companies, either on the hardware side or on the software side or both,
Sure.
who are meeting with foreign heads of state, You weren't seeing that 5 years ago. You're seeing it now.
Yeah.
So it's just a remarkable time, and I can't wait to see how it shapes up.
Yeah, no, I couldn't agree more. What a great time to be alive in our industries, huh?
Indeed, indeed.
Alex, thank you again so much for your time. This was a really exciting and illuminating conversation.
Thanks for having me.
Yeah, of course. You're welcome to be on Wired In anytime. If you're ready to explore more on this topic, check the description below for additional resources. And don't forget to hit that like and subscribe button to stay wired in.